What I'll be talking about today is going to be very simple, very clean, very short. Basically, I'm talking about, let me just first get you thinking. You know that if you have a glass, say a glass filled with soft drink, soda, and you fill it up to brim, and then you take a block of ice, and then you drop it. Don't like drop it with like force, but you just drop it, place it. What will happen is that if it's up to the brim, it will spill. Like your soda will spill, just fall to the ground. Why is that so? Because you've added weight, you've added an extra volume. I'll get into that soon, but what I mean by volume, you've added another volume. Basically, there's something called the buoyancy force. I'll get into it some other time. Stay tuned for more videos. So like basically, you have this buoyancy force that just makes the soda spill on the floor, off out of the cup. So basically, then people think about this. People think that ice adds the volume. Wait, let me just explain this real quick. If you take an ice block and then you place it inside a cup, an empty cup, and then you fill up the cup with water or whatever until it reaches the brim, whilst the ice is inside, what's going to happen is that the ice is going to melt, right? The, when the ice melts, what do you think is going to happen? What do you think? You're probably watching this video and you're like, yeah, I know the answer. I know what's going to happen. Well, let me just do that. Let me just do that with you real quick. So to demonstrate what I was talking about, right here with me, I have something that's a very easy setup that you could do even yourself. I have a block of ice, and I have water that I've made a bit too warm. Actually, it's a bit warm. So what I'll do right now is I'll take any random block of ice right here, and as you can see, the water's not exactly up to brim, although I could take it up to the brim, but okay, just add the water. Okay, now I'll carefully add well, it's not really up to brim, but you would assume that if I place this ice right here, let's first see what's going to happen. Now it's up to the brim, exactly to the brim. Well, I guess for the sake of the video, we have to watch this ice as it disappears. So basically, what's happening here is that, as you saw, the water kind of raised. Now, a person could ask themselves that, now, the ice is melting right now, so there's water that's exiting, if you want to say it like that, but there's water that's basically coming from the ice, but that water is not adding up and it's not just spilling. Why is it not spilling? What's happening? Now, as you can see, you can probably see by now that the ice is almost gone. Actually happened faster than I thought. Well, if I add some more right now, it's just gonna spill. So, but for the sake of the video, I'll add some, and a little will spill. But what's gonna happen now is ice is gonna stay constant. After it spills, it's not gonna spill again. Okay, we saw that. But now watch this. Will it spill again? Let's just watch as this malevolent phenomenon takes place. As you can see, the ice is melting really fast. So what's basically happening here right now, for those that are going like, this is so cool. As you can see, no more is actually spilling out, but only the one that's already existing. So to further explain, an ice block like this, it has its own volume. It has a volume. You can calculate the volume if you have the equipment and the equations. Basically, as simple ice as that is basically it's water that is frozen. Water that's frozen as an ice. And when you place an ice and begins to melt, what's happening is that the water that is less the temperature of the actual ice, so that means the water that is above a certain temperature, maybe the ice melts at 100 degrees Celsius. If the ice goes above that temperature, then it begins to lose that rigid shape, that shape of solid, and it becomes a. Now, to properly use an equation to express this thing, what I've explained as the buoyancy force, which I said I will make a video about later, stay tuned. What you see right here is that this is what science has done to me, burns me. Well, this is the equation to express the buoyancy force, the force that I was talking about. That if you have a, a glass and then you place a liquid inside this glass of water, there's a force that this ice block is exerting, which we call the buoyancy force for later topics. So essentially, what I'm talking about right now is that this volume, this part of the equation, the volume, that the volume of this ice block, this ice before it was ice, it was liquid, it was a form of liquid, and so then went to ice. It's basically like we took this pocket of liquid and we just froze it. It's not even basically, that's the actual thing. We took this and we froze it, and then it became this. And as it's now this, what's happening is that it kept the same volume. It's still the same volume. So if you place it inside a glass of water, let's say maybe, that is, if you first place the ice and then you place the glass of, and you place water inside, which is at the brim, as this over time, as it melts, it's not gonna overflow. It's not gonna do that. It's gonna keep this very simple. As you can see with the pictures right now on the screen, what the buoyancy force is, Archimedes principle. Yeah, so yeah, that's basically the most simply as I can put it.
Well, as I said before, that this video was just to make a statement that I'm still alive and I'm well, and I hope you guys are well too, and you can share, like, subscribe, leave a comment if you're feeling generous. Well, until next time, this time and the next time.